Hi, can you hear me? Yes. Awesome. So my name is Maciej Najbar. And for our foreign friends, the pronunciation is Magic Neighbor. I needed to start with a joke for myself, not for you, so just to feel calm. So today, I'll be speaking about the abstraction. We don't realize how obvious it is for us to use it on a daily basis, and somehow we ignore it when we write the code. So let me ask you this question. Does it make sense to create an abstraction for just one implementation? How many of you think it does make sense? Can you raise your hands so I can see them? Not many. Okay. How many of you think it doesn't? Just a couple. Thank you. And how many of you think it depends? Yeah. Okay, so thank you. This is a very general question, and the most common answer to it is, it depends. I strongly disagree, and I would say abstract everything. Let me show you an example. 23 times 12 equals 276. I bet you're familiar with the way they teach us at school to do the math, right? We place the numbers, one on top of the other, and we multiply. 23 by 2, that's 46. 23 by 1, that's 23. We add these numbers, and we get the result. Did you know that in Japan, children are taught to multiply by drawing lines? Let me show you. So we take number 23, and we draw lines, separating tens from ones. Then we take number 12, and we draw perpendicular lines the same way. The result is pretty much counting the meeting points. Genius, right? That was my reaction when I saw it for the first time. Someone had found a graphical way that enables us to multiply two numbers and simplifies the process. The abstraction makes it possible for us to come up with different solutions. But first things first. Simon Sinek, in his book Start With Why, explains how the answer to the question why can inspire people to take action. If it's still not on your reading list, I really recommend it to add it right now. I'm just going to take a sip of water to give you the time to take a picture. So this book organized my thoughts. I always knew the power of context, and I always knew the power of abstraction. I just never realized that they are tightly connected. He presented it in a book in the form of a simple graph. He called it a golden circle. He says that every single company in the world knows what they do. Some of them know how they do it, so they can tell you how they differentiate themselves from the competition. But only few know why they do what they do. And he says that the traditional marketing works like this. They start from the outer line of this golden circle, and they go inwards. They say, we make great products. Our products are beautifully designed and easy to use. Do you want to buy them? It doesn't seem right. So basically, no one wants to be talked to buy something, but every single person here wants to buy something, right? In the contrary, he explains how Apple does it. So Apple starts with the center of the circle. They start with why. And they say, we challenge the status quo and think differently by designing beautiful products that are easy to use. And we happen to make great products. Do you want to buy them? They get straight to the heart of the consumer. Buying an Apple device just feels right. So it got me thinking that in software engineering, we basically have to answer all these three questions as well. I just changed the order, because in my opinion, we just do it in a different order. So we start with why. We should start with why. If you needed to take away one thing from this presentation, in my opinion, it should be this. The answer to the question why sets a context for your task. Context can change everything: a priority, a plan, and a solution. Then you should ask what needs to be done. It's not just a to-do list. The well-prepared plan is an organized scope of work. There's this famous saying: if you don't know where you're going, how will you know when you get there? Let's be honest, we cannot prepare a perfect plan because we cannot foresee all the circumstances that may occur. Only by knowing the answers to both why and what, we should ask ourselves how we want to do it. How many times it happened to you that someone asked you to do something and you started to think which library suits most to the task that they were asked for? Like in this example, mom texts you, "Can you fix my phone?" Without knowing the context, you don't know what she means, right? She could break her screen, or she could install the virus on her cell phone. So if you started with how I want to fix it, you would probably be preparing for all the possible circumstances. Probably I will need a screwdriver, tape, a new glass, a cable, etc. And then you get another message that gives you the context. I can't find pictures. For your mom, it's the same thing. She just entered a different directory and she cannot find pictures of her beloved grandson. So how does Y affect what? Every single company sets some goals. These goals can be represented in some kind of milestone. So it's in fact a plan, right? So let's go with this example. We need 100 holes. You must agree that this is not a perfect plan. I didn't specify how deep they must be or where I want you to dig them. So let's add a context to it. We need 100 holes because treasure is hidden here somewhere. If you will be looking for the treasure, your holes probably will be very, very deep. And also, you'll be looking for the landmarks, like a tree, a stone, or something that makes sense where the treasure might be hidden. Let's change the context. We need 100 holes because we want to plant 100 trees to overcome global warming. Now, your holes will be shallow, and the distance between them will be enough for the trees to grow. Also, if you see your team member doing something wrong, by knowing the context, you will be able to correct him. How does Y affect how? So we need to answer this question, how we can create a hole. For sure, we can use a bulldozer. You've seen it on many building areas, right? We can use a shovel, but we also can create a hole with a stick of TNT, right? So let me add the context to it. I look at you and I ask, a stick of TNT? That might destroy the treasure. You think this guy is right. So we will rent the bulldozers. And I can add another point of context. I can say, you know what? We are short on money. Okay, then we will buy shovels. And I look at you and say, like, we are really, really short on money. If you believe me that the treasure is here, you can come up with alternative ideas by knowing the context. And you can tell me, okay, we will find this treasure and we will dig it out with our bare hands. So now we know how the context matters. But how does it apply to the abstraction, you might ask? So what is abstraction? The abstraction to me defines behavior. The behavior can be a process. Like we can do some things in a specific order. Let me show you my favorite example. It's not that. Okay. This is my favorite example. I want to make a cup of tea, but my kettle is broken. So if I needed to create an abstraction for it, it would be just an interface with the function make the tea. But if my implementation was tightly coupled to this kettle, I would have no choice. I would have to fix it. So we have to think, like, what is the process of making the tea? So we boil water in a kettle, we place the tea bag in the mug, and once the water is hot, we pour the water into the mug, right? So during this process, we have some smaller processes as well, like, for example, boiling water. How we can boil water? We can, of course, use the kettle, but also we can boil water in a pan. Or we can pour the water into the mug and place it in the microwave, right? But this, in fact, changes also the process, because we will be able to put the tea bag into the mug only when the water is hot. But this can be replaced also with a kettle solution, because we can boil the water first, pour it into the mug, and place the tea bag into it. So basically, the abstraction makes it possible for us to juggle around with the implementations. So if we know how to create abstractions, the question is how to name them. When it comes to coding, I think that we are overcomplicating the class names. We come up with ideas like a manager, handler, helper, or utils. You must agree that these are not the perfect names, although we can find them in our code. Why? It's probably because our classes missed abstractions, and they were growing with functions that together in one class were hard to be named. If you think about the abstraction, that it defines the process, defines the behavior, naming interfaces becomes easy. Also, if it's hard to be named, think if the abstraction is correct. So like in this example, the interface, we have a function to boil water. My recommendation for naming the interface would be this. Read from right to left and make a noun out of verb. So, boil water becomes a water boiler. Watch out, here comes a joke. Hot or not. So the reader reads, the writer writes, the water boiler boils water, right? Don't get me wrong, I'm not saying that abstraction should have only one method. Fun fact, on a very low level, in most cases, yes. Such interfaces are named functional. I can read and write code. I'm a programmer. I can read and write articles. It makes me a journalist. Jeez. I can read and write articles. It makes me a journalist. I can read and write books. I'm a novelist. I can get even more general. I can read and write, period. I'm an author. Programmer is an author. Journalist is an author. Novelist is also an author. So, if I create a method, create project, you author, I can pass any author, and the project will be created. If I change the type to a programmer, I definitely mean to create a program. It's amazing how abstractions give us the idea of what is going on. And it works both ways. I could read and write, I'm an author. I don't have to tell you what the lawyer or chef does. You know that one represents you in a court and the latter cooks. So I'm a programmer and I can drive a car. If I needed to create a class of myself, it would probably look like this. Class, magic neighbor, programmer, driver. But if something breaks down in my car, I cannot fix it. The mechanic can. He can also drive. He doesn't have to have the driver license, but for sure he can drive. And now you caught me. I didn't name the interface by its function name. I forgot to mention that it's not a rule, but it's a method. But it doesn't stop me from creating an interface, the car fixer, because the car can also be fixed by an enthusiast. Do you know where I'm going with this? The more granular you get, the better abstractions you can create. So abstractions define what they do, what they accept, and what they return. But abstractions are not silos. Sometimes they know about each other. When two abstractions know about each other, it's called a contract. The most common example of a contract is the MVP architecture pattern. The view knows about the presenter knows about the view, and they know how to communicate with one another. Bear in mind that I didn't name it an architecture, but architecture pattern. These are two different subjects. The architecture, according to Robert C. Martin, in Screaming Architecture, should give you the idea of what the application is based on the use cases it contains. The architecture pattern is a pattern that helps us organize the code. It is based on design patterns. Like, for example, the MVP design pattern, architecture pattern, is a bridge design pattern. The MVVM or MVI, they are using the observer design patterns. And I mentioned design patterns not by mistake. Many clever people solved our problems a long time ago. Design patterns, most of them, are based on abstractions. And like, for example, a facade can be also called an API. You hide the backend behind the abstraction, and it doesn't matter to you if it's written in Java or Go, right? Or a bridge design pattern. It's a two-way facade. One abstraction knows about the other, and they know how to communicate. If you ask me to multiply 4 by 9, I just bend my fourth finger, and I can see 3 fingers on the left, 6 on the right. That's 36. If you ask me to multiply 13 by 100, I just add 2 zeros to the first, and I get the result. If you ask me to multiply 23 by 12, I will draw the lines. Else, I will use the knowledge from school. Did you see what I just did? I created the strategy design pattern with different solutions. We should also talk how not to create abstractions. So let's play a game. Is that a good abstraction? And that's a spoiler alert. A programmer that can cook. Is that a good abstraction? Wrong. The DTO that has its own interface. Is that a good abstraction? What do you think? No? Yeah, and you're wrong. And you're right. It's wrong. So maybe that. An interface that accepts other interfaces DTOs. Is that a good abstraction? What do you think? Because you're spooky. It's what? It's okay. Exactly. That's probably wrong. Because it is up to us to define if something needs a contract or not. It's intuitive, isn't it? So if we want, like, for example, in the MVP architecture pattern, the view knows about the presenter and the presenter knows about the view, right? So we created this contract. And basically, if the designs change, the presenter will be affected, if we want it or not, right? Because some widget probably will be a new one and will need an action on click. But what if we wanted to create a payment processor and we use some vendor's transaction DTO? If our company starts a partnership with another vendor, this new vendor does not know anything about the first vendor's library or DTOs. So we failed on designing the abstraction. But what about the view model? On the left-hand side, you can see the example from the tutorial. They say that, it's from the Android. So basically it says that you should create a private value field that is mutable live data, and the live data is just an observable field that you expose with the immutable live data for the view to subscribe. But inside the view model implementation, you are using this private field helper field with an underscore prefix. Doesn't look clean, right? You have two fields for just one purpose. So what is an alternative? We can create an interface with the live data exposed for the view, and we can overwrite this live data with a more strict type of mutable live data that derives from the first. And we can use this view state inside the view model like normally. But everything comes with cost. Now, our interface is tightly coupled to live data library. But in the first one, the view is tightly coupled to the view model's implementation. So we can call it a lesser evil. What should not be abstracted? The DTOs. They should not be abstracted because they should be defined by the abstraction. As we already agreed, the abstraction defines what they accept. So here, the use case tells us what kind of parameters it accepts. Or when we design the API, the API tells us what kind of request it will accept and what kind of responses it will return. I don't mean that the DTOs should be enclosed inside the interface body, but they should live close though. Like in this example, we can place the remote objects inside some package because they can be reused by other endpoints. When it comes to the params in a use case, I would really recommend to enclose them inside the interface body. First, they are immediately visible, immediately accessible, and also the params keyword will be repeated multiple times. So when you are trying to look for the params, you will have a list of all the params that you actually don't need. Singleton. Singleton is considered as anti-pattern. I disagree, but that's for another discussion. But they should not be abstracted. They cannot be abstracted. So I cannot think about a real-world example for the singleton. Like, think about the Earth. It's a planet. Think about the sun. It's a star. Think about the Milky Way. It's a galaxy, right? Even the universe is not considered as one and only anymore. So why do singletons exist? Treat them as a patent for your code. If you create the SDK or the library, you don't want to give the possibility to the implementer to create multiple instances of your class. Because, I don't know, maybe it's the resources load too long, or it's a memory management or something like this. This is when you seal your class with a singleton. So this should not be abstracted. What is a solution? So I know it's obvious, but I need to say it. It's an implementation of the task. If your task is to hammer a nail into the wall and it's not straight, until your manager notices, that's fine. Keep in mind that you don't only work for your own pleasure. I hope you do, but not only. You work for your clients. They are the most important because you work for money, right? And the money flows from your clients. But you cannot satisfy everyone. And thanks to Pareto rule, also known as 80-20 rule, you don't have to. 80% of your work will take 20% of your time. 20% of your clients account for 80% of the company's profit, more or less. So basically, you just need to satisfy the right clients with the right features. And if they don't use the app like you think they do, it's a waste of time to work on it. It's a MVP mindset, right? The example I have from the real world is that in my previous company, I was working, we just released the feature for, I missed the word, for the markup. So if someone wants to buy someone buys something and wants to sell it with a profit, they add some a couple of percent markup to make this profit, right? And later, they asked us to create the discounts. So we implemented this calculator that we take the amount, we calculate 10% discount, and we subtract it from the amount. But then, when the complaints started, because our clients told us that this is not how it works. If they buy something and they want to sell it with 20%, and we calculate 10% discount, we basically give them 12%. They told us that we want to subtract the discount from the markup. It works, for example, when they have a service and they charge us 100% price, subtracting 10% gives us 90%. But if we add this markup, this is not 100% anymore. So thanks to the fact that we had the interface for these calculations, we could easily replace it with a different implementation. Floating interfaces around the code gives us another advantage. We can mock the classes. We can mock these interfaces in order to test it. And that's a huge advantage because we can fake the input and see if the output matches the expectations. So one can say that classes can also be mocked, for example, by using a Mockito library. And I was wondering how Mockito can mock classes, especially when they are closed and you cannot derive from them. So I examined this library, and if I got it right, they create the new types that are hidden behind the serializable interface, and they create the wrappers for the classes it mocks. But that's something that you need to verify on your own. So you should be able to test your code, and you should be able to test your implementations. You should be able to feature flag your implementations. And I don't mean to add the if-else blocks inside the implementation. I mean to test the implementation. I know it's sometimes adding the if-else blocks is necessary, but it should not be the rule. You should be able to replace entire implementation. So, for example, you got a new endpoint. That's great. You should create a new gateway that uses it. It will accept the different object, but we will have to return the same thing, just not to break the previous state of the app. Did you optimize your code? That's great. You should be able to create an abstract factory that returns one implementation or the other based on the feature flag state. This way, you can collect the data from the field and see if your solution works as expected. If it doesn't, just disable the feature flag. Sometimes, the implementations know about each other, and they are tightly coupled. It's okay when the implementation is just a delegate for the first one. This way, you can just limit the size of the files, but basically you keep the entire implementation in one place. And like in this example, we create a new gateway, and we add the specific mappers for these gateways. They will accept different data, and they will have to adapt, right? So adding the abstraction over these mappers that are created specifically for this implementation does not make sense. So believe me, if you create the PR like this, I will close my eyes and I will hit approve. The last thing I wanted to talk about is the domain layer, and why is the domain not abstracted? So domain is set for specific business. Every business operates differently and has a very different language. Domain is to establish this language cross teams. So if everyone in your company calls an order a ticket, Why would you name your class in order? To create confusion? So we had this situation when we were working on a feature in the current company. We had this feature that the payment industry calls incremental auth. And it works like this. You call for an Uber, and Uber authorizes $20 for your ride. But the driver takes a detour that costs extra $3. So Uber increments this authorization for $23. But everyone, like all our merchants, and thus everyone in our company, calls it Start It Up. It's a very restaurant-specific name. So when creating this use case, we decided to name it exactly that, to be able to communicate on the same level. This way, developers can work with the product team, developers can work with the merchants, basically everyone knows what is going on. So what I want you to take away from this presentation, first, you should be asking why we are asked to create some feature. Only by knowing the context, you will be able to come up with different solutions, and you as developer can also have amazing ideas. So ask for the context to give yourself a possibility to contribute to the greater cause. Then you should ask what we need to do. You should create a plan. Like on the project level, you should probably create a user story. On a code level, you should prepare abstractions. And then you should ask how we want to do it. So only by knowing the answers for those first two questions, you should start figuring out what is the solution. So what would be your answer now? Sorry. Does it make sense to create abstraction for just one implementation? Thank you.